In Lesson 5, we're going to continue to identify the unit rate and look at it in rate situations. If you take a look at your workbook, page 15, you're going to see 4 different rate situations. We're only going to do 2 together. Now, all 4 of them, they're telling you they are rate situations, so you don't have to determine whether they are or aren't. And each one, you're going to go through and identify, what the unit rate is, and then we're going to fill in the table, just like we had done in the past. So let's look at number 1. Every day of this week, Joanne made 3 of her free throws. Okay, so that sounds like she made 3. I'm just going to do free throws here. 3 free throws per day. Right? It was every day of this week, but it was every day that she made 3 free throws. So in this case, my unit is going to be the days, and my product then is going to be the number of free throws. I'm just going to abbreviate that as FT. So let's see, on the first day, well, obviously Joanne would make 3 free throws. On the second day, well, now we're up to 6 because she has done 3 more free throws. Now on the third day, okay, again, another increase of 3 free throws. We're up to 9. Fourth day, now we're up to 12. Another increase of 3. So you can see that we have a constant rate of 3 free throws per day. You can also, show it with multiplication. 2 days times 3 free throws is 6. 3 days times 3 free throws is 9. 4 days times 3 free throws, there's your 12. So you can show it with the addition. You can also show it with the multiplication. Now, one of the other things that I want you to do is I want you to think about the situation. I want you to think about what you're assuming here, and is that likely? Is that something that really could happen in real life? So let's think about Joanne here. Do you think it's possible that every day of this week, Joanne made 3 of her free throws? I guess it just means that she must be playing basketball. I'm going to assume that she's playing basketball every single day for a whole week. I'm also thinking, she must be stopping after she gets to 3. Have you ever done that where you practice and practice and until you get to a certain number then you can stop? So I'm kind of assuming she's stopping at 3. Otherwise she could have kept going and maybe she could have had 10 free throws per day. But I'm going to assume that she's stopping at 3. So this is a situation that you can relate to real life, but you also have to think, is this something that really could happen, and what are we going to assume about that? Looking at number 2, Efren makes 8 sketches on each page of his drawing book. So that would be 8 sketches per page. So on every single one page, he has 8 sketches. So here, I know my unit is the number of pages, and then the product would be the sketches. So on one page, he has 8 sketches. That means on the second page, we're going to be up to 16 sketches. On the third page, we're up to 24. And now by the fourth page, wow, we've got 32 sketches done. So what's been happening is he's been increasing the number of sketches that he makes by 8 every single page. Again, you could also show that with some multiplication. You could do 2 times the 8 sketches to get 16. 3 pages, 8 sketches per page, now we're up to 24. 4 pages, 8 sketches per page, now we're up to 32. So in this case, let's see, can this be possible? Is this something that could really happen in the real world? I guess it could be, yes. For every page, he's stopping at 8. What he might be doing is he might be breaking his page up into 8 sections and then using each of his 8 sections for, one of his sketches, one of his drawings. So I guess this could be pretty likely. You can finish the rest of this page on your own. I want you to keep in mind, think about these situations. Could these really happen in real life? You know, is this something that's kind of likely or unlikely? Now on the next page, on page 16, you're given a couple different tables, but again, you have to determine whether or not they're actually rate tables or not, and then you have to explain why or why not. So I'm going to do 2 with you, and you have to do the other 2 on your own. So let's see, if you remember, a rate table must have 2 columns. They look like they're columns right off of the multiplication table. And they also show a constant rate, a constant increase. So let's see, if I look at number 5, I can see that this is my ones column, right? I'm increasing by 1 every single time, 1, 2, 3, 4, 5. Now this column, let's see, this looks like my nines column in the multiplication table. 9, 18, 27, 36, 45. It looks like I'm increasing it by 9 every single time, or you can even say multiplying by 9 every single time. So in this case, I would say yes, it's a rate table. And maybe I'll write constant rate of 9. So yes, that's definitely a rate table. Now let's look at number 6. Alright, well this column, the very first column, definitely looks like my ones column from the multiplication table. I'm counting by ones. This column on the right though, I don't know. 4 to 5, that's an increase of 1. But then 5 to 9, well that's an increase of 4. And then 9 to 10, that's an increase of 1. And then 10 to 14, that's an increase of 4. Yeah, there's a pattern there, but it's not constant. It's got to be exactly the same, never changing. So in this case, I would say no, and then semicolon, no constant rate. We are adding with different numbers every time. It's not the same. And when you get down to number 9, you get to make up a story about one of the tables and label that table. So, I don't know. For example, maybe I like number 5. I like how we're increasing it by by 9 every time. Let's say that I brought in 9 cookies per student. So maybe this is the number of students. And then this could be the number of cookies that I bring in. So every kid would get 9 cookies. So one student would get 9. Alright, well now if I have 2 students, I better bring in 18. Oh wait, if I have 3 students, I better bring in 27, and so on and so forth. So I wonder how many cookies I would have to bring in if there were, I don't know, 25 students. You get to do that for maybe number 7 or number 8 or even number 6, even one that's not constant. You can come up with a situation that belongs to it, or kind of goes along with it, and then label your unit and your product column. Now, if you look at the bottom of workbook page 16, it says for each rate situation, find the unit rate and write it using per. Make a rate table that includes the given information as the first row in the table. So the given information must be in the first row. And then we're going to be making a scrambled rate table. So a scrambled rate table, as you can probably guess by the name, is a rate table where it's not necessarily in order. It's a little more scrambled up. So let's see. Number 10, the store sold 5 sacks of oranges for $30. So that's the very first information that we're given. 5 sacks of oranges for $30. So it sounds like sacks is our unit. That's how many we're going to have equal groups of. And the product is going to be the dollars, the amount of money for each of those sacks of oranges. So let's see. What is the unit rate here? How much is it for 1? I know that it's $30 for 5 sacks, but how much is it for 1 sack? Well, what I can do is I can think about what would I need to multiply to get to 30. If you remember, we always did the unit times the unit rate to get our product. So we have our unit, which is 5, we have our product, which is 30, but we're missing the unit rate. We're missing how much it costs for 1 sack of oranges. If you know your math facts, you probably can figure out that it's $6 per sack. 6 is the missing number. So that means it's $6. Oops, I should probably have dollars as my label here. $6 per sack. So if I want to continue filling in this table, and again, I want to make a scrambled rate table, so I want to mix it up. What if I said there were 7 sacks of oranges? Well, 7 times 6 would be 42. What if there were only 2 sacks of oranges? That must be 12. Remember, this is a scrambled rate table, so I don't have to go in sequential order. I can mix it up a little bit. What if I'm talking about 10 sacks of oranges? 10 times 6 is 60. So there's my scrambled rate table. You can see that sacks is the unit, dollars is the product, and my unit rate, the amount for 1 sack, the amount for 1, is $6 per sack. And if you look down at number 12, number 12 says to make a math drawing to show the very first row of the rate table in exercise 10. So my very first row, if you remember, was 5 and 30. 5 sacks for $30. So if I want to make a math drawing to go along with it, I don't know, maybe I'll make 5 sacks. So here's 1 sack, and that costs $6. And then here's another sack of oranges that costs $6. And let's see, I'm going to make another sack. And I think I need 1 more sack to make 5 sacks total. So there's my 5 sacks of oranges, and each one costs $6, which shows you a total of $30 for the 5 sacks. You are going to have to try doing number 11 and number 13 on your own. Okay, takeaways. A scrambled rate table is basically a rate table that shows the constant increase, but it does not go in sequential order. So it does not have to go 1, 2, 3, 4, 5. It can be in a different order. It still shows that constant rate though. In a rate situation, you are assuming that the rate will not change and will remain constant. So if you think about those tables, you know, we were talking about the number of free throws, those types of things. I'm going to assume that she's making that same number of free throws every day, that it's always going to stay the same. So I'm probably assuming, you know, she's playing basketball every day. I'm assuming that she's stopping once she gets to 3 and, you know, she finishes her practice after that. So remember, in a rate situation, you are assuming that the rate will not change.